Alright guys, so today we're going to be going over remote interior and exterior angles. Now we already covered remote interior and interior angles, but we're going to do a little bit of a review. So the first thing I'm going to do is put my name on my paper. So my name is Ms. Hurst. Alright, name's on my paper. Today's date is 12/14/16. And I'm in every period, so I'm just going to put all. So now, I have everything labeled. I'm going to go through and start taking a look at these pictures that they told me about. So the first thing I see here is I have these shapes where I need to know what's going on with my sides here. And we're going to start talking about these things called exterior angles. Well, exterior just means they're on the outside, right? So exterior just means they are on the outside. So you'll see I drew a line out there. I've just created an exterior angle. All right, this is the angle that is on the outside if I were to extend every side. So what I'm going to do is I'm going to grab up here and I'm going to use my dotted line again. And I'm going to go through and do all of those angles real quick. All right, everybody. So now we have quickly drawn in all of our little segments and lines to make all those exterior angles. And what I did was I numbered them. So at this moment in time, go ahead and copy that down into your notes. All right, so now that you have that copied down, we're going to go through some quick vocabulary. So of course we know exterior angle. Well, exterior, that just means outside, right? Okay. So we have an angle that is outside of our shape. In this case, it is an angle formed by a side and the extension of an adjacent side. So it is an angle formed by a side and the extension of an adjacent side. What's really important here is that the sum of all of these exterior angles is 360 degrees. That's going to hold for every single picture that you're going to have, okay? It doesn't matter what shape you have, what polygon, nothing. All that matters is that it is 360 degrees. So if we look up in our picture up above, we have a lot of exterior angles. It's going to be numbers and angles, numbers 1 through 14 are all exterior angles up there. So for example, angle 6 right here is going to be an exterior angle. So now I'm quickly going to go through and label all of my interior angles. One of those are going to be something that is inside and all right, so as you can see, I went through and I labeled all of my interior angles in green. Now, interior, as we said before, just means inside. All right, so I have angles that are inside my shape. Now, once I have that my angles are inside, what I can do is I can go through and say where they are. Well, what's another word for shape? Good, it's polygon. So an interior angle is just an angle inside of a polygon. Now, if you don't remember, how we find how many degrees are inside of a polygon is by adding all of those angles together. But we can also use that formula of n minus 2 times 180. That will tell me the total number of degrees inside my polygon. So now, once I have that, what I can do is I can go through and see what else is going on. So in this case, I need to say which angles are considered to be interior. So if I look up here, I started with this blue number 15, and I went all the way through to down here where I have 28. So I'm going to say that angles 15 through 28 are interior. Now, if you look down below, we have remote interior angles. Well, those are dependent upon the situation, right? We have multiple angles that can be outside. What it tells me is it's the non-adjacent interior angles of the exterior angle. So for example, if I go up into my picture and I look at, let's say, exterior angle number 3. Okay, I'm going to circle that. Exterior angle number 3. The non-adjacent interior angles there would be numbers 19, 17, 16, and 15. So we're just going to give ourselves an example. So if I say, for example, I have angle 3. That's my exterior angle. What I'm going to say is then I have angles number 19, 15, 16, and 17 are my remote interior angles. Now that I know all of my vocabulary, what I can do is I can go in and find all my missing angles in the polygons down here. Now, the thing that's important to point out is that these are regular polygons. Regular polygons mean that all the sides are the same and all the angles are the same. So because I know that, I can say, all right, how many sides does this shape have? Well, I can go through and count. I got 1, 2, 3, 4, 5 sides. I'm going to write that in the center. It makes my life easier. I know that if I have exterior angles, the sum of those is going to be 360 degrees. So if I have 5 sides, all I have to do is divide 360 by 5. So I write down 360, and on the outside I put my 5. Well, does 5 go into 3? No. So I put a 0 there. 5 goes into 36, though. How many times does 5 go into 36? Let's think about it. 7. Good. So now that I have that 5 goes into 36 7 times, what is 5 times 7?
35.
35. So that means that I know I need to write a 35 down here. And 36 minus 35 is?
It's 1.
1. And I bring down that 0. Good. So then how many times does 5 go into 10?
2.
2. So then I take 2 times 5, which gives me?
10.
10. Subtract them and get?
0.
0. I got nothing left. So that means that 360 divided by 5 is 72. So over here, I'm going to write that x is equal to 72 degrees. So now I'm going to go through and find z. I'm going to do the same thing as I did before. First thing I'm going to do, figure out how many sides I have. This one's pretty easy. We're used to looking at triangles. We know they have 3 sides. But just for consistency's sake, I'm going to go through and label everything and say 1, 2, 3. I got 3 sides.
Isn't that an equilateral triangle?
It does happen to be an equilateral triangle.
And it's 60 degrees.
Yeah,
right?
Each angle here will be 60 degrees. So we actually have 2 ways that we can find what z is. We could use our exterior angles, or we could say, well, this is 60, and what's this thing they're sitting on again?
Line segment.
A line segment. And how many degrees are in a line?
180. Right?
180s are in a line. Good. So that means that if I did 180 minus 60, I should find out what z plus 20 equals, right?
Correct.
And what is 180 minus 60?
120.
120. So I have 2 ways I can do this. I could say that z plus 20 is equal to 120 because I have a line segment, and I can remember that a line has to add to 180 degrees. Or I can do 360 divided by 3. So I'm just going to write that over here so you can see it. You will get the exact same thing. 3 goes into 3 how many times? 1. 3 goes into 6 how many times?
2.
And
0.
0. So look, we still got 120 and 120. It works both ways. Now I've set my z plus 20 equal to it. And we go through. So how do I undo plus 20?
Okay, what you want to do is subtract the 20 on both sides.
All right, that both sides is really important to say. So now we have that z is equal to what?
100.
Good. Z is equal to 100. And that's our whole problem. We now have everything that we need.
Now, could you say if the points were A and B, could you add up 60 that way?
So you're saying if I had an A here and a B up top,
Right.
if I knew these two angles and they're both 60,
Correct.
okay, so yes, you can. If I knew that these are both 60, it is an equilateral triangle, so I do know that. What I can do is I can say, well, these two angles have to complement, or not complement, supplement whatever this angle down here is in blue. And so whenever I add those, I get 60 plus 60. I also get 120 that way. So there's actually 3 approaches to this problem that we could take. Take your notes, show your notes to either Ms. Lyles or Ms. H. And whenever you're done with the worksheet, you can turn that in.